Hi, I'm Maya Zachrin, and did you know that just like I'm talking to you, bacteria can talk to each other too? Well, bacteria can't really talk to each other, but they can tell when there's a lot of bacteria in one area based on quorum sensing. They can tell when there's a high population density and when there's a low population density. Here's the difference between high population density and low population density. In this image, you could see that there's one bacteria in a large amount of space. This means that there's a low population density because there's a lot more room for the bacteria to grow and thrive without running out of space. In this image, even though there's only one bacteria, there's a high population density because there's a smaller amount of space. So there's a larger amount of bacteria per unit of area. Over here, there's also a high population density because there's more bacteria per area of space. And when you have a high population density, you have quorum sensing. To sum this up, a high population density means a higher amount of bacteria per area, and a high population density means that quorum sensing can occur. Quorum sensing bacteria produce and release chemicals called autoinducers that increase in concentration as a function of cell density. This image shows that when there's a low population density of bacteria, the amount of autoinducers, represented by the red triangles, is limited, as compared to when there's a high population density of the bacteria, there's a lot more autoinducers released. This image shows the relationship between the amount of autoinducers versus the amount of bacteria. As the amount of bacteria increases, the amount of autoinducers increases as well. This image shows the different phases a bacteria goes through during quorum sensing. So right here in this image, you see only two bacteria. They are not ready to attack. They could sense that there's only a low amount of bacteria present based on the amount of autoinducers there. Since they're not ready to attack yet, they'll wait until they reproduce and create more bacteria. Here the bacteria are almost ready to attack. You could see that the autoinducers represented by these circles are increasing in numbers, which tells the bacteria that it's almost time to attack. And here, there's the optimum number of bacteria to attack. So since they sense that they could attack, they go for it and they attack over here. So now this is what happens during quorum sensing on the cellular level. First, a chemical reaction triggers this triangular molecule to produce the quorum sensing autoinducer. The autoinducer then leaves the bacteria, travels to another bacterium, where the autoinducer gets recepted by their recepting molecule. The recepting molecule triggers another chemical reaction, which either tells the bacteria that it's ready to attack or tells the bacteria to produce autoinducers. It's pretty cool, right? Between plant animals and unicellular eukaryotes, most quorum sensing bacteria are alike, even though these kingdoms diverged over 1 billion years ago. This shows that quorum sensing was necessary before multicellular organisms were able to be created. I hope you learned from this video more about quorum sensing.